Today I'm going to be doing another little test instrument overview, and I'm going to be talking about the Leader LTC-906A, which is the one I have. I think there's another model is called the LTC-906, which is a similar model, but I think what it has 3 extra LEDs, and what those LEDs do, I think, is they identify the collector. This one will identify the base, and the other model identifies the base and the collector. Of course, then by process of elimination, you would know that the third lead is, of course, the emitter. That's probably, if I bought this unit again, that would probably be the model I would get then, the LTC-906. Of course, I didn't know that when I bought it. And the only user manual I could get for this thing was for the LTC-906. Anyways, this thing checks, supposedly it checks normal transistors, diodes, FETs. I've got the handbook here. UJTs, unijunction transistors. I think those were transistors that were kind of like diodes, but I really don't remember. It's not like I ever am going to test something like that. Now, there are 2 different test sections. One is for doing out-of-circuit tests, which is this section here. And this section here is for doing in-circuit tests. Now, to start out, I'm going to be doing an in-circuit test, and I'm using an old leftover circuit board. And it does have a transistor on there, and right now I've got the 3 leads of the Leader transistor checker actually hooked up to that. And what's going to happen now is you can hook these, basically you hook these leads up. It doesn't matter which lead is what. They can be all mixed up, because what the unit will do, it'll tell you which one is the base lead, and also it'll identify if it's a NPN or a PNP transistor. And of course, if it's bad. So let me go ahead and demonstrate that now. Of course, not knowing which is the collector or emitter, it is a little drawback. Okay, but basically, if you're doing like an in-circuit test, I mean, if it works, if the unit shows it's actually good, then I really don't worry about it anymore. But if the unit shows it's bad, then you got to double check. Then of course, best thing to do is take it out, look at the schematic, see if anything else is hooked up to the transistor, which could be causing the transistor checker to show bad. So what I do then, I pull it out of the unit, then I check the transistor again, which is actually also the proper way of doing things. Now let me talk about the layout here first. You see it's got a scale here. This is check the battery. This one here is for the base emitter voltage drop. And here GE or SI, germanium silicon. And of course your top scale here, your mirrored scale, that is leakage, and gain leakage is in microamperes. This here is your 0 adjust for the pointer when it's off. And if we go over here, we've got good, bad, good. We've got 3 LEDs, and one of these will be basically flashing if it's good, either this one or this one. And one on the left here, if it flashes, this will tell us, okay, this is a PNP transistor. And if this one flashes here, it'll say it's an NPN transistor. And of course, if this one, where it says here bad, if that stays on, then basically it's saying that it's bad. Now in circuit, of course, what you can do then, you might, if there's a heavy load on this thing, you might have to go to high drive and try it out that way. If not, as I said, you'd have to pull it out of circuit. But overall, this unit has been pretty reliable, I have to say. And of course, it's got like a buzzer thingy. And you got your leads here, and you can also, of course, push the leads of a transistor down into the little sockets there. Hopefully I can get this back in there. and you got three LEDs here, and depending upon which one basically lights up or flashes, that'll tell you, okay, which one is the base. And your mode here is transistor diode, and the drive low high, which I had just explained. Up here, your auto function, that's in circuit. Your DC parameters, that's out of circuit. Of course, here self-explanatory: power, battery check, on. And here you got your different switches for different functions. HFE, which is the gain, the leakage, and the base emitter voltage drop. And here, if you're checking out of circuit, you need to put this switch in the correct position for NPN or PNP. And this is your range switch, which you can do adjusting when you're actually doing the testing. And here, this color chart, this is how you're supposed to hook things up then when you're out of circuit. Base blue, collector green, yellow emitter. And of course, this is how this is supposed to be plugged in here. You notice here the correspondence: blue, green, yellow. And that's how you hook this. There's the wires here. One's blue, one's green, one's yellow. You don't have them backwards. You put them in so the colors actually correspond. We go with the in-circuit test, and we put the switch here in the auto position, and now it's showing me bad here, which can't be. Okay, you can see here it's showing now good because I had the leads shorted to another on the circuit board. And this is what it's supposed to be doing here. It says here this is an NPN transistor. Good is flashing. And if we look here, we notice here the LED here, number 3, which is the yellow square basically. And that's the yellow lead here, what I've got here in my fingers. And now I just got to follow it over to the end of the leads where the leads are attached to the transistor, and that tells me which one is the base. So this flashing one here is the base, and that would mean over here, that would mean this yellow one here, which was this outer one, is actually the base. And if we look down here, we could actually see here it says B. That was the right lead is the base, and so that's absolutely correct. That would have been right here at the end there. And of course it does the same thing. If this would have been a PNP transistor, then this over here would have been lit. And of course you get a little buzzer too. So much for the in-circuit test. Again, if it would have shown bad in-circuit, then the next thing I would do is put the drive high. And then if that still would have been a problem, then I would have went ahead and taken the transistor out of circuit and checked it again. So how would I figure out what is the collector and what is the emitter? So I put the unit in the auto test function here, and I've got everything hooked up, and you can see here this LED here is blinking, tells me the transistor is good. Also that it is a NPN transistor. And over here you can see this blinking here, the number 3 LED, and the yellow color tells me it's this yellow test lead here. And if I follow this, I can see here that it's the middle lead, and the middle lead, or the pin of the transistor here, is the base. And of course the collector and emitter are the outer leads. And now I don't know which one is which. What I have to do next now is put the unit in the auto function. So, no, excuse me. What I have to do next now is put the unit in the DC parameter function, which I am doing now. But I have to change one thing. The connection, I have to put the base now has got to go on the blue lead. So the blue lead is this lead. That's got to be the base. That's what this little color chart there is for. So I put that on the base. Again, I know that one then is the base. So either the green or the yellow lead here coming up to the transistor leads going to be the collector or emitter. So what do I do next then? Next I go to the HFE position, and of course this switch here has to be in the NPN position, since I know this is an NPN transistor. So I'm in the HFE position now, and notice here I've got like 0 gain, right? So but if I were to switch the leads around here, then I should be getting something according to theory. Yeah, I actually am. You can see right here, I'm on the times 10 scale, and it's almost here. It's about 118, so it's a gain of 180. Of course, when I had it the other way around, it wasn't showing me anything at all. It could show something, but I know one thing though, if the transistor's hooked up correctly, then that's when I'm going to get maximum gain, and this is it right now. So that tells me the yellow is then, here is the emitter, or I'll turn this around here like this, so the writing on the transistor is to the front. Yellow is to the emitter, and the outer lead here, the right outer lead, that is the collector. So basically that's how that works. Now we can also check the, of course, germanium transistors and diodes. These germanium diodes and transistors are always going to show a higher leakage. You can see right here, I think I'm in the leakage position, and it's showing me 80, I'm on the times 1 here range, and if I go up to here, it's on the 80, and it's showing me it's got 80 microamperes of leakage. Of course, see here it says ICEO. The ICEO, that means the current between the collector emitter with the base open, is what that means. Let me just get a silicon diode to demonstrate the difference. Now, for contrast, here's a 1N, I think it's 4148 silicon diode, just to show the difference. Here, if we go to VBE, you can see its forward voltage drop is 0.7. And if we go to the leakage position, you can see the leakage is basically about, can't be measured here. And even though this is this way, even though both of these diodes were good, the one just showed more leakage, a germanium diode, and this barely shows, or really doesn't show anything at all. So yeah, that would explain that. Now I'm going to show what happens when a transistor is basically bad. You of course hook up the leads to the transistor, and color coding or nothing, it doesn't really matter. It doesn't really matter at all. Of course, when I talk about green, yellow, and blue here, I mean the color of the test leads here, the wires, not the actual probe ends. These are 2 black ones and 1 red. So then I turn the unit on, I put it in auto, and then over here you'll simply see the red LED will light up bad, and that's going to be it. The transistor is basically bad. So I think I'm going to have to stop my rambling for now, because this video is getting kind of long. I could, of course, keep going on and on, but I realize the audience for this is limited and people don't like to watch really long videos. Would I recommend getting this? Yes, I would. I think I paid around $25 for mine, and these can still be found online sometimes. And I mean, look how long this thing has been around. I think it's made in the 80s, and it'll probably be around a lot longer. I plan on keeping mine, even though I've been looking online. There are newer transistor checkers out there, like you can get from China. I think there's one called I think it's a T1 or T4 or something like that, with the OLED screen, really small thing. But I don't know how accurate those are, really. But I would go ahead and recommend, if you can get this LTC-906A or you can get the LTC-906, I would recommend go ahead and getting that. This thing also, I think it takes a 9-volt battery, and you can also hook up DC power supply to it. And it's actually pretty lightweight. And I think that's about all I have to say about it for now. Also, there is a online manual available. I think it's for the LTC-906. But that can be downloaded for free. Anyways, thanks for watching.